0. Fourth grade, thank you for engaging in our do now. Now we're going to go over the answers that we got. So our job is to find the mean and the median of this data set, and the data set is represented as a line plot. So how did you find the mean for this data set, Jonathan?
So I added up all of the values and the amount of people that, like, all the X's, and I got 24.
Okay. So to start, Jonathan added up all of the values to find the sum. We got 24. What is the next step, Jacob?
You divide that by the number of values.
Okay. So divide 24 by the number of values, which is
10.
all right. And Matthew, what is 24 divided by 10?
24 divided by 2 is 2.4.
2.4. So 2.4 is our mean, which is our average value of this data set. Now let's talk about the median. How would we go about finding the median, Sabrina?
You put like 1, 2, 3, 3, 4, 5, 5, and then you like put your fingers or cross them out until you find the middle.
Okay, so putting our data points in order from least to greatest, and then going, what you were saying, going towards the middle until we find the exact center. So what was our median, Bianca? 2. All right, give me a thumbs up if you got the mean and the median today. All right, well, lots of thumbs. Thank you. We can push thumbs down. So now that we are experts in finding the mean and the median, we're going to take it one step further with our line plots and figure out which measure of center best represents the line plot. So the mean and the median both talk about the center of a data. They're both measure the center, but one is better than the other in some situations, and that's what we're going to talk about today. So what is our learning target, Simon?
Asking mathematicians look at a relation of center that best represents a set of data.
Nice. Okay. We have 2 success criteria today. What's the first one, Rena?
Modify line plots to fit certain criteria about measures of center.
Okay, thank you. So we'll have our line plots as we've been working with. We're going to make changes to our line plots in order to do what, Rolando?
Determine find the median with every descriptor of a data set that then the median.
Okay, awesome. So for our work today, turn your iPads over. Go log on to Pearson if you haven't already. We're going to Unit 8, Lesson 6, Slide 3. Let's do that in about 30 seconds. Unit 8, Lesson 6, Slide 3. When you get there, there is an interactive, so go ahead and click on it. Unit 8, Lesson 6, Slide 3. Okay. When you get there, the interactive is a line plot missing all the essential features. So no title, no label for our number line, and of course, no data values. What's up? Oh, mine isn't on. If there's a network issue, just force it out of the app. So in our work with statistical questions, these are questions that we can answer with multiple ways. So an example of a statistical question we did a few days ago was the number of pets in the class. So let's take another look at that and title our graph 3 to 4 pets. Okay. All right, so I'm modeling it up here. Go ahead and follow along on the screen. And then the label for our number line will be number of pets per student. Now we have the title, we have our number line labeled. Now we need to start adding some data points. Okay, how many pets do you have, Deja? 5, 6 pets? Okay. Huh? All right, she has 5 pets, so we'll click on the eraser and then put an X on 5. How many pets do you have, Memphis?
6.
6 pets? How many pets do you have, KJ? One. How about you, Joshua? 64 pets. 64? Well, good thing we can use this feature. Scroll all the way to 64. Okay. That's going to be what we call an outlier because it is far away from all of our other data points. How many pets do you have, Kaya? Matthew? 6. Smyrna?
2.
Elias?
1.
How many do you have, Weston?
0.
Okay. How many pets do you have, Talia?
0.
How many pets do you have, Evelyn? And James?
6.
Sabrina?
4.
4. Isabel? 3. Indara?
0.
Anybody else that wanted to share the number of pets? Bianca?
4.
All right. Anybody else? Last 3. Rolando? Michael?
0.
And Charles? 1. Okay. So here is our line plot. Just keep in mind Joshua has 64 pets, so that is way to the right on our number line. But if we look at the bottom left corner, the mean and the median are already calculated for us. So if we look up on the screen, KJ, what is the mean of this data set? What does it tell us? 5.7. So the mean is telling us the average point is about 5.7. What about the median? What does it tell us the median is, Matthew?
It says the median is 2.
Okay, and our range is 64. Because we have a point at 64 and a point at 0. Alright, and the range is the greatest value minus the smallest value. That's 64. So we are going to be making some changes to our line plot so that we don't forget what our line plot looks like. Take a screenshot. So hold your power button and your circle button at the same time. Okay, if you screenshotted it correctly, you should have a little rectangle in the bottom left corner that looks like a screen. Alright, give me a thumbs up when you have your screenshot. So if you ever need to go back to look at the original line plot today, you can go to your photos and pull up the most recent screenshot. Alright, thank you for your thumbs. Now let's get to the point of what we're doing today. There are 2 measures of center, the median and the mean. We want to figure out which one best represents this data. And we're going to do that through a series of questions. So the questions that I'm going to ask you right now mirror the questions on your lab sheet today. So we know that the mean of this data set right now is 5.7. What happens if we add a value above 5.7? So try that on your iPad. Add a value anywhere above 5.7. I'm going to do 8. So now that we've added a data value above the mean, what happened to the mean? Charles, what happened to the mean? When we added a data point above the mean, what happened to the mean? Did it go up or down? Yeah, increase. Okay, who else made that observation? Give me a thumbs up. Okay, majority of the class. Okay, so click the eraser, hit whatever point that you added and erase it. Now we're back to what we started with. Now what happens if I add a data point below the mean? So our mean's 5.7. Choose a place to add a data point below the mean. I'll do 1. Okay. What happened to the mean, Trevor? Did it go up or down?
The mean was
exploration today, you will be working with altering our line plot and looking at what happens to the mean and the median. You will be working with your A and B partners, so that is your shoulder partner. And when I get the lab sheet passed out, you will have 15 minutes to explore. Are there any questions, Rolando? You sure?
I'll ask you.
All right. Okay. Go ahead and get started. I will pass out your lab sheets. All right, thank you for engaging in our work time today. That was about 20 minutes of hard work. Now we're going to summarize our findings. So if you look over at the welcome board, we have a T-chart graphic organizer. I noticed a lot of you started writing down into your math notebook. But now we're going to finish this T-chart to document our observations. So the two measures of center we have are the mean and the median. And when we added data values above the mean, what happened, Leslie? What happened to the mean?
The mean increased.
Mean increased. Give me a thumbs up if you noticed the same thing, a thumbs down if you did not. Okay, see lots of thumbs up. Thank you. Now let's talk about what happens to the mean when we added data values below. What happened, Nada?
The mean decreased.
The mean decreased. Okay. Leslie and Nada, were these big increases or little increases? Little, okay. Did anyone else notice big increases with the mean when you added data points above and below? Matthew, you did?
I mean, if you put the numbers far enough away from, I guess where the mean is, then it'll decrease a lot or increase a lot.
Okay, so Matthew noticed our mean was at, I believe, 5.7. If you added a data value way above 5.7, the mean increased a lot. If you added one way below 5.7, it decreased a lot. Good observations. All right, now let's talk about the median. Simon, when you added values above the median, what did you notice?
Stay the same.
Stayed the same. Okay, and then what happens when we added data values below the median? Emlyn, what happened? What happened to the median when we added data values below? Did it increase or decrease? Or stay the same? Stay the same. So as I was walking around, I saw some of us found the median might have increased or decreased a little, but a lot of us found this interesting observation where the values of the median stayed the same. Okay, these are some observations that will help us determine whether the mean or the median is a better fit for our line plot. So I know that you can see the mean, the median, or the line plot in front of you, but I'll also put it on the whiteboard. Bianca, did you have something to add? What's up?
I just tested something out and then I added numbers below and the median didn't decrease.
Okay. So it could decrease. It could increase. But was anyone able to add data values above and below the mean and the mean stayed the same? Okay, you might have been able to do that too. Alright. So when we talk about a measure of center for a line plot, we want either the mean or the median to best describe the data. So now let's make some observations about our line plot. Is our line plot, is all the data in one area or is it kind of spread out? And don't forget we do have that point at 64. Michael, what do you think?
It's spread out.
It's spread out. Okay, what else do we notice about the shape of the graph? Raina?
Most people have 0 or 1 pet.
Yeah, so we have a lot of people that reported 0 or 1 pets. Okay, so that would be our mode, right? So here are some things that I've heard that we noticed. We noticed the line plot has a spread, okay, all the way from 0 to 64. We can't see the 64, but we have one person with 64 pets. And we have a mode of 1 or 2. or 0, 1. So taking all these observations into account, these are going to help us decide whether we use the mean or the median. So we know the mean changes pretty much wherever we put a point. The median's a little bit more stable. Okay, it doesn't really matter where we put the point. It could increase, it could decrease, but it also might stay the same. So when I say go, turn and talk to your table groups. Do we want a mean that changes a lot when we talk about a line plot? Or do we want to use a median that stays pretty stable when we talk about this line plot? All right, about 30 seconds to talk with your groups. That changes a lot, or a median that stays Well, think about how we have it only changes. Think about how we have is the median affected by that with the median not so much. Alright, I hear that our conversations are coming to a close. So in thinking about whether we want a mean that changes a lot to talk about the center, or a median that's relatively stable to talk about the center, what do you think? I want to hear from 2 people. Bianca, what do you think?
I think that the median.
Okay. Bianca says we want to use the median because it's more stable. Remember, we do have that point all the way to the right at 64. That impacts our mean because it impacts the sum. All right, but what about Elias? What did you think?
I got the median, and the median doesn't get changed that much the further away the point is.
Tell me more. Why would you say that?
Well, because like the mean will get changed a lot, but the median won't.
Okay, so that data point at 64, when we talk about the mean, that 64 gets added to the sum of all the numbers.
Yeah.
But as far as the median, it's just a value that we cross off and we try to get to the middle, right? So let's take a class vote. If you think the mean is better, raise your hand, or if you think the median is better. So start with mean. Okay, 4 of us. And how about the median? All right, thank you for voting. You can put your hands down. It seems to me that the median is the better representation of the measure of center of this data. Okay, so to wrap up the big idea that we talked about today, if the data has a wide range, or there are outliers, so that outlier at 64 way off on the right in the distance, the median is a better descriptor of the data because the mean is more affected by extreme values and outliers than the median is. So to wrap up our thoughts today, go ahead and write this big idea down in your math notebook. And I will go ahead and pass out your exit tickets, and that will conclude our lesson. Okay? Thank you.